A rod has a length of 1 meter. When it is in a satellite moving at a velocity of 0.8 c related to the laboratory. What's the length of the rod according to an observer in the satellite and the laboratory? Here the rest frame is a laboratory, moving frame is a satellite. The velocity of the satellite is 0.8 c. A rod of length 1 meter is present inside the satellite. According to the concept of length contraction, L is equal to L0 into root of 1 minus V square by C square. Here, L is the length of the object predicted by an observer in the rest frame. L0 is the length of the object predicted by an observer in the moving frame. Now we may introduce the concept proper length. The length of the object measured by an observer who is at rest with respect to the object is called proper length. With respect to the rod, the observer O dash is at rest, whereas the observer O is in motion. Now read out this. The observer in the satellite is at rest relative to the rod. With respect to the rod, the observer O dash is at rest. The length of the rod measured by him is L0 equal to 1 meter. The length of the rod, according to an observer in the laboratory, is L is equal to L0 into root of 1 minus V square by C square. Here the value of V equal to 0.8 into C. Therefore, L is equal to the value of L0, 1 meter into 1 minus 0.8 C whole square divided by C square. L is equal to root of 1 minus 0.64, that is equal to root of 0.36. Then L is equal to 0.6 meter. Now we may point out, for the observer in the satellite, the length is 1 meter. For an observer in the laboratory, the length is 0.6 meters.